Synergy UHD4 imaging platform is a commanding video system offered by Arthrex, featuring an Ultra HD 4K programmable camera head, LD xenon bright light source, and an image management system, and a fiber optic video, all in one tablet-controlled device. So this is the tablet that allows us to take images and videos for all of our test cases. And then we have the screen that takes in a feed from the camera and reads it onto a computer that allows the surgeon to see inside the body part. Due to developmental reasons, we decided to perform our experiments on an ideal case. Our setup involves a medical instrument that is placed perpendicular to an arthroscopic camera. We consider the cases where the instrument is allowed to move over one axis of rotation and move at different distances away from the camera. For our setup, we are using a conceptual prototype where instead of engraving a deliverance sequence on the surgical instrument, we printed the same pattern on a pen.
Okay, so the first part of our algorithm intakes this initial frame, and doing some calculations with the thresholds and parameters and some filtering, we were able to find the exact lines that we want, shown right here, the bright green lines. And you can do a side-by-side comparison to seeing what is being cropped out after using those green lines to calculate the width, height, and the angle of which you want to crop out. And it moves on to the next part of our algorithm where it reads the pattern.
So from Ethan's code, we take the input image, which is shown here, and we find the reference and the De Bruijn bits, and from there we can find the De Bruijn sequence, which tells us that we're in this case on section 23 of the instrument and 46 millimeters away from the instrument, the tip of the instrument.
Okay, so in the final part, we're inputting the section number of the first visible bit we see and the coordinates of the ends of the instrument from the previous two segments of code. We're also using pixel to distance ratio, which is the number of pixels per millimeter. And we use these inputs to determine how many pixels to shift along the instrument for reaching the tip. So this is our output, and the center of the X is the estimated location. We also calculated accuracy. So we are 1.24 millimeters away from the actual tip.